Hi, good evening friends. My name is Bonu Sampath. So before going into the topic, we have to take an example. So I have taken an object. So let us consider this as a torchlight. So I have focused the light on this object. So after reflection or refraction, where would the image form? So to know where the image is formed, we have to know about the topic, the ray diagrams. So ray diagram is a diagram that traces the path that the light takes in order for a person to view a point on the image of the object. In simple definition, to know the image of the object at different positions on the principal axis, we take the help of the ray diagrams. So let us consider an object on the principal axis. So when I focused a torchlight on the particular object, you can see that a number of rays which are passing through the object. So you may ask me, which rays are to be considered while drawing the ray diagrams? Yes. So we consider the standard incident rays while drawing the ray diagrams. So the first standard incident ray is the ray which is parallel to the principal axis would pass through the focus after reflection or refraction. The second one is a ray which is passing through the optical center. It doesn't deviate its path after reflection or refraction. So and third one is that a standard incident ray which is passing through the focus would become parallel to the principal axis after reflection or refraction. So first let us consider the ray diagram of convex lens. So convex lens is basically a converging lens. So what is a converging lens? So after the refraction, all the rays would meet at a point. So it is called as a converging lens. So let me consider an object placed at the infinity, which a very far distance. So we can't name it. So because it's at the infinity, let us consider two rays which are coming parallel to the principal axis, down the principal axis and up of the principal axis. So after refraction, where would the rays meet? Yes, it's at the focus, because the standard incident ray is about a ray which is parallel to the principal axis would meet at the focus. So after refraction, it met at f2. So what type of object is formed? Yes, it's a real, inverted and very highly diminished, right? So second, let us consider an object placed beyond the C, that is beyond the 2f1. So let us draw the ray diagram. A ray which is parallel to the principal axis would meet at the focus, right? And a ray which passes through the optical center would meet here. So where was the object formed? Right? So it is formed between f2 and 2f2, and it is real, inverted image and diminished image. Now let us consider a convex lens and an object placed at 2f1, that is at the center of the curvature. So let us draw the ray diagram. A ray which is parallel to the principal axis would pass through the focus, and a ray which passes through the optical center would not deviate its path. So it's a error while drawing. So if we draw correctly, we would get the image at the 2f2, that is the other side of the lens. So the image is formed at the 2f2, and you know that it's a real inverted image. And what is the size of the image? Yes, it's the same size. Now let us consider an object placed between 2f1 and f1. So let us draw the ray diagram. A ray which is parallel to the principal axis would pass through the focus, right? And a ray which is passing through the optical center, right? I have to extend it more. It doesn't deviate its path. So error, but it would meet at some point beyond C, right? So we can say that. So you have observed that an object when placed at the infinity, the image is formed at the focus. So when an object is placed beyond C, it is formed between f2 and 2f2. And an object placed at 2f1, the image is formed at 2f2. And an object placed between 2f1 and f1, so what is that? It is beyond 2f2. The same way, so when you draw an object on the focus, where would the rays meet? Yes, it is at the infinity. Let us draw it. So when an object is placed at the f1, so where would the image form? So let us draw the ray diagram. A ray which is parallel to the principal axis would meet at the focus, and a ray which passes through the optical center. So you can see that the two are parallel rays. So we have a condition that the parallel rays would meet at some point at the infinity. So we can say that an object when placed at the focus would meet at infinity. So it's easy to remember, guys. So when an object is at infinity, it would meet at the focus. When an object is beyond C, they would meet at between F and C, you can say. And an object at C, that side of the lens, it's center of the curvature, and an object when it placed between F and C and F, it is formed beyond C, and an object at F, it is formed at the infinity. And you have an exemption when an object is placed between focus and optical center. Let us draw it. So when an object is placed between F and optical center, so where will the image form? Let us draw the ray diagram. So with the ray parallel to the principal axis would meet at the focus, right? And an object at the optical which pass to the optical center would not deviate. So they are not parallel, right? So let us draw backward, right, with the dotted lines. So you can see that the object is formed at F and the same side of the lens. So this is only the one exemption, which is, so when an object placed between F and O, the image, that is the image is formed at F1, the same side of the lens, and it is virtual and erect image. So now let us consider the concave lens. So basically the concave lens is a diverging lens. So what does the diverging mean? So it would diverge the path, it would not meet, right? So I have taken an object at the infinity. So let us draw a parallel rays down the principal axis and up the principal axis. So divergence would mean like this, right? Would diverge in the path like a torchlight. So let us extend it backwards. So error, but it would actually meet at the F1, that is same side of the lens. It's a virtual and erect. And what would be the size of the image, guys? Yes, it's nothing but the enlarged image. So now when an object placed beyond 2f1 or at f2f1, between 2f1 and f1, at f1 or between f1 and O, the same image will be formed. So I have taken an instant that object placed between 2f1 and f1. So let us draw the ray diagrams. A ray which is parallel to the principal axis. It's a concave lens, right? It diverges its path. So it would meet at the focus, the back side of the mirror. And if you draw this ray which is passing the optical center, would not deviate its path. So where is the image formed, guys? Yes, it's a virtual image, an erect image. It is formed at the same side of the lens. It is formed between f1 and O. So if I take this all these instances, so I can get that image at the same side of the lens and between f1 and O. That's why I have taken all the concave, all the positions of the object would form the same image. So I think you have understood the topic, how to draw the ray diagrams of concave and convex lens. So keep practicing and good luck, guys. Thank you.